Imagine holding three completely different materials in your hand: a shiny metal spoon, a soft pencil lead, and the hardest natural substance on earth, diamond. Here's the crazy part. They're all made from atoms, so why are they so different? The answer is hidden in something called chemical bonding. Hi everyone and welcome back to Academic Avenue. Today we are going to master ionic bonding, covalent bonding, metallic bonding, and how bonding controls the properties of substances. By the end of this lesson, chemistry will make much more sense. So stay till the end because I'll also share exam tips and practice questions that frequently appear in IGCSE and O-level exams. Let's start with the biggest question. Why do atoms bond at all? Atoms bond because they want stability. Just like humans try to reach comfort and balance, atoms also try to achieve a stable electron arrangement. The most stable atoms are the noble gases because they already have full outer electron shells. Other atoms try to copy this arrangement by gaining electrons, losing electrons, or sharing electrons. And the electrons involved are called valence electrons, the electrons in the outer shell. Remember, this bonding is all about outer electrons. Before going deeper, let's quickly understand metallic bonding. In metals, the outer electrons become delocalized. This means they are free to move throughout the structure instead of staying attached to one atom. Imagine positive metal ions floating inside a sea of moving electrons. That attraction keeps the metal together, and this is exactly why metals conduct electricity, conduct heat, and can be bent without breaking. Now let's focus on ionic bonding. Ionic bonding occurs between a metal and a non-metal. The metal loses electrons and becomes a positive ion called a cation. The non-metal gains electrons and becomes a negative ion called an anion. Since opposite charges attract, strong electrostatic attraction forms between them, and that attraction is called an ionic bond. Let's see the classic example of sodium chloride, common table salt. Sodium has one electron in its outer shell. Chlorine needs one more electron to complete its shell. So sodium transfers one electron to chlorine. Sodium becomes Na positive and chlorine becomes Cl negative. Now both ions are stable, and because they have opposite charges, they strongly attract each other. That forms sodium chloride, NaCl. Now here is something important. Bonding determines properties. Ionic compounds have high melting and boiling points because the electrostatic forces between ions are very strong. They conduct electricity, but only when molten or dissolved in water. Why? Because the ions are free to move and carry charge. They are usually soluble in water and they form beautiful crystal lattice structures. Now let's move to covalent bonding. This occurs between non-metals only. Instead of transferring electrons, atoms share them. Each shared pair forms one covalent bond, and both atoms attract the shared electrons. This keeps the atoms together and form molecules. Not all covalent bonds are the same. Single bond, one shared pair of electrons. Example, hydrogen. Double bond, two shared pairs. Example, oxygen. Triple bond, three shared pairs. Example, nitrogen. And here is the important concept. More shared electrons means stronger bonds and shorter bonds. Let's look at some examples. Hydrogen, the simplest molecule. Oxygen contains a double bond. Carbon dioxide, carbon forms double bonds with oxygen atoms. Methane, carbon shares electrons with 4 hydrogen atoms. These are all covalent compounds because electrons are being shared. Simple covalent substances usually have low melting and boiling points because the forces between molecules are weak. Even though the covalent bonds inside molecules are strong, the intermolecular forces are weak. They do not conduct electricity because there are no free ions or electrons. That's why many covalent substances are gases or liquids at room temperature. But not all covalent substances are simple molecules. Some form giant covalent structures with billions of atoms connected together. Examples include diamond, graphite, silicon dioxide. Because strong covalent bonds extend throughout the structure, these substances have very high melting points, are very strong, and are usually insoluble in water. Now here's one of the most important comparisons in chemistry. Diamond and graphite are both made entirely of carbon, but their structures are different. Diamond, each carbon atom bonds to 4 others. This makes diamond extremely hard, transparent, and unable to conduct electricity. Graphite, carbon atoms forms layers. The layers can slide, making graphite soft and slippery, and graphite conducts electricity because it contains delocalized electrons. Same element, different structures, completely different properties. Now let's revisit metallic bonding in more detail. Metals contain positive ions arranged in layers. Their outer electrons move freely throughout the structure. This sea of electrons creates strong attraction between the ions and electrons, and that's what gives metal their unique properties. Metals are conductors of electricity and heat because electrons move freely. They are malleable, meaning they can be hammered into sheets. They are ductile, meaning they can be stretched into wires, and they usually have high melting points due to strong metallic bonding. Let's compare the bonding types quickly. Ionic bonding involves ions, happens between metals and non-metals, and conducts electricity when molten. Covalent bonding involves molecules, happens between non-metals, and usually does not conduct electricity. Understanding these differences is very important for exams. The type of bonding controls physical properties. Stronger bonds mean higher melting points. Free electrons allow electrical conductivity. Structure determines hardness, solubility, and flexibility. This is why chemistry is not just memorization, it's understanding patterns. Here are some exam tips that can improve your answers immediately. Always mention electron transfer for ionic bonding and electron sharing for covalent bonding. Use scientific terms like electrostatic attraction, shared pair of electrons, delocalized electrons, and never confuse atoms with ions. Atoms are neutral, ions are charged. And that's the end of today's lesson on chemical bonding. If this video helped you, like the video, share it with your friends, and subscribe to Academic Avenue for more IGCSE and O-level science lessons. Comment below which bonding type do you find hardest, ionic, covalent, or metallic. Thanks for watching, and I'll see you in the next lesson.